In this section, we're going to practice adding or subtracting rational expressions. As you see here, I put a subtraction problem. I think that's a little bit harder than an addition problem because if this it is a monomial, but if this numerator was a binomial, we would have to distribute the negative sign. One of the strategies or the organizers that we've used in class is breaking up the denominators into primes. It's kind of silly for a problem like this because these guys are already broken up as far as they can go, but you can use this for a lot of the problems that we're going to do in class. Since there's really nothing in common, we always say that 1 can go into anything, and if we multiply by all the leftovers, we would have a 3 and an x and the x plus 2. Sometimes students like to say there's an x in common, but again, we have to see this as a grouping. So technically there's nothing in common besides the 1. So the LCD then would be all of those things multiplied together. Notice that just staring at it, we need to have an x plus 2 over here, and we need to have the 3x over here. You see kind of where I squeezed them in here? I did it afterwards, so if I wanted to distribute, I could. Here I put it in front, so if I wanted to distribute, I could, and be in a nice format. Many of you can just look at it and just see what the LCD would be, the least common denominator. So if so, you can skip all this. All right, the point of the LCD is so that we have a common denominator, and typically we don't multiply back in together because we're hoping that some things are going to cancel. Up on top, though, I'm going to distribute 10 times x is 10x, and 10 times 2 is 20. Over here, I have 3x and another x, so it's 3x squared, and make sure that you see that we're subtracting that. Again, if this was a polynomial, you'd have to subtract each one of those terms. To wrap this up, I'm going to put it in descending order, so I'm going to put the x squared term first, then the x term, followed by the constant. And for you mathematicians out there, you can think ahead. Perhaps in the future, we might want to try and see if this factors, and if it does, we might want to go cancel crazy again. Good luck on this section.